audio. Oh, so I know. So now the audio should be on. So yeah, let me tell you again, hello. So nice to see you in the chat. Hopefully you can hear me and see me now. Let me know in the chat if it's the case. Is audio and video okay? And then let's start. Okay, great. Great. So first of all, I asked you to get the template, so that's hopefully in the progress. And meanwhile, so it's great that you already know how to interact in the chat using plus, so that's great. Yeah, so meanwhile, I will look at one of the homeworks that I received. So that's really useful to get the homeworks so that I can give you some guidance with regards to the things that you do. Otherwise, if you don't submit homeworks, I don't know what you know and what you don't know. So here, there's one homework. So this is, I think, like reasonable attempt of making the kind of spaceship in the top screen. So let me try to run it and show you how it looks like right now. And then let's discuss some of the issues with this code, and then let's get into today's topic. So, okay, first of all, I get this kind of strange behavior. That's because I need to set so I will show you again. So I need to set okay, this is actually not the correct code. Okay, this one. Yeah, so this is the correct one. So I need to set here in the settings that this is emulate terminal output console, right? Okay, that's great. So let's then look at what we have here. So if I run it, hopefully it starts. So yeah, so it looks something like this, and I can move around, and I can even shoot this spaceship here. So that's really nice. So those things are working, even though the score didn't increase. It was not quite easy task to make the score increase, but it didn't. And also the spaceship didn't. So let's look what's wrong with the code. Oh no. Oh no. My computer froze. That was not expected thing. Okay, hopefully you would so hopefully the live stream did not lose me. Okay, I will be more careful. There is something in regards to the interrupts of the keyboard that somehow tried to kill my live stream. Okay, hopefully not. Hopefully there will not be a problem. Okay. So let's go one by one. So first of all, we have this alien class. So this is actually the spaceship, but still it's alien. So here I see that after creation of this thing, you call move to the right and move to the left. But of course, this is not possible to kind of do both things at once. So if we go like inside this function, you have the template basically, like already you can look at that. But you go in that function, you see that we set direction in direction of x-axis +1, y0, right? And then for the left, we set x -1 and y0. So the second call here actually overrides the first one. So this one will set direction x +1, and this will set direction x -1. Plus, also, the other thing will happen is that it cannot actually move in the minus direction, because if we look how it's created, where it's created here, so it's created then at position x0 and on this one side of the game, I guess, like very strange way how to set it, but still. So if that's the case, if it's set to that position, yeah. So in that case, it cannot move in minus position because we have the check here. If we scroll up in the class of position 2D, there is a check scene, and if this is a minus position, it doesn't allow to set minus position at all. So this doesn't make sense, at least right now. So what we could do instead is set that it can fly in the right direction. So that should be okay. And what else here? So let's also add this score thing. So I see that you try to make a class of score, but this is not necessary at all. So why would you need to make some like a class for the score? Because you make classes except for the singleton. For all other things, you make classes only for things that you use many times. If you have like one value of score, you do not make many classes of scores. There's just one value. So you don't actually need to create this kind of like object with class with score. You can, but it's not necessary. So let's see what we have here. Then there is a score here. First of all, there are two lines. Probably the first line is not needed. Just we can stick with the other line. Then this syntax is a little bit strange that you add the comma here, so it makes this part as a tuple, but it's actually not doing anything. So, but anyway, so let's add here score. So score will be 0. I know that other students do not have this code. It's just then please look, and you can make better code. So anyway, so score, you can either write it like that, but would be better to use it using the F syntax like that. So we have score. Oh, by the way, no, okay, so yeah, I will drop these things also to the Jamboard, slide number 2, just in case somebody want to explore this kind of direction more. But anyways, this is specific to this code, and we will soon move to the template. So there we have the score. So this I added to the Jamboard already. So just let me find. So then, what else we have here? So I also changed the way how alien move, or basically spaceship. So I will add that as well. But it will not be enough, so we will make a few changes so that at least this kind of homework submission works at least in some reasonable manner. So I added those things. Then what else we have here? So here is very interesting code. So you say that if we have collision with alien, then we should destroy it, right? So maybe some very simple way how to change something here would be if we add if this one, so if this one is alien, or the element A or B is alien, then in that case we will add the score +1. So we increase the score, right? So this would be the way how to change the scores. So, but of course this is not optimal, but this is one way. So I will add also that to the Jamboard. Now, if you run it, so let's see, it should, so let's see something. Yeah, so the alien is slow, the spaceship is slowly moving in that direction. So if I try to shoot it down, oh, okay, it shot down that. Oh no, I will miss it. Yes. So let's see what happens when it reaches the other side. It should be stuck there, and then I can shoot him down. Hopefully it's stuck, not error. So yeah, it's stuck, and now I can take him. Yeah, but we should make that he tries to fly away in other direction. So to make him fly in another direction, so let's see how to do that. So remember that object-oriented classes can override all sorts of things. Oh, I just realized that you have score as an element here, something like this. Let's see where you use it, this thing. So you don't use it actually, but this is even more a little bit wrong. So in the sense that element is anything that is kind of like object that is in the game, you know. That's why we created element ourselves. If we go to the element, you see that this is position, this is like direction, collision. This is nothing related to the score, you know. So the element class is only about the kind of all of the characters and things flying around. They are not related to the score in any way. So the only way where kind of the class makes sense is a game state singleton that you will have in the new template, and you can then explore it a little bit later. In general, it's not necessary here at all. So this part should be better deleted, but hopefully you get it that this is not necessary, because either you have this game state or you have just like the simple variable with score. You don't need anything more difficult than that, like very simple stuff. So that part is fine. Then regarding the alien, so of course we can override things. So if we try to override update function, right? Because like in object-oriented polymorphism, we can change the function code of the child classes, right? So then we can call the super update delta time like that. You can even leave this parts out. So that's nice. We can update it, but then what we can do is we can flip the direction around. So if round, or let's say if int self, so the cell int will be the lower, like the floor of that. If self position x is 0, so if we are reached the left side, or round, so when we round it upwards also, self position, self position y is equal with the scene width -1, because as you remember that the arrays have the upper bound, how many elements you can put in the list or array is always the index itself starts from 0, so you need to have -1. So that part, if any of these two are true, then what we want to do is to have self direction. Where is direction? Yeah, direction x. And for the direction x, we want to flip it around. So we want to fly in another direction, right? So multiply by -1. So this syntax, as you know from before, is exactly if we would write it like this, right? So we flip the direction. We have the other, like the inverse direction. So now if I run it, let's see what happens. So I'll try to not shoot him down. Okay, so the problem is that it's stuck. Okay, so it is stuck. It's probably changing direction all the time from one side to another side. Let me think about it. Yeah, so let me think about it. Okay, so we could, so if it reaches 0, and now direction is on the right side, so it, oh, by the way, we should then probably not have the integer rounding here. Could work like that. Let's see if it works like that. Yeah, so now it's flying on that direction, because it will be rounded by the, so actually also here, we don't need that, because it will be bounded inside the position 2D class till the 0 till scene width -1. It will never be actually in the other direction. So let's see, it probably could stuck also on the other side. Yeah, I think it's stuck there. Okay, so we can leave it like this, and maybe let's make it much faster so I just like can make sure that it works. So, okay, so now it's flying, 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 reaching the end. Not flying back. Okay, let's see. So add a breakpoint. Maybe there's something else happening here. Okay, so I'm adding the breakpoint. So it's flying, 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 reaching the end, nothing happening. Why it's nothing happening? So this, right. I don't know what I was thinking about. So you see, I use position Y. This is position X. So now it will work, hopefully. By the way, I added these things to the Jamboard if Cristiano wants to fix it. So, okay, now it still doesn't work. This is so strange. So, okay, I will add again the breakpoint. It should work. There's no reason why not to work. Okay, so position X. What is position X here? Oh, sorry. Edit position. Come on. Okay, position X. So it's not actually bounded because why it's not bounded actually. So we added that position. That is interesting. So added position here, and then here where's the bounds? I know why it's not bounded. So it's actually not allowing to set that value, but at the same time it doesn't prevent you to have value that is very close to the 0 just before setting to 0. So maybe would be better to change this part. So I guess the better way how to set this part would be to have minimal value of either a scene width -1 or value, or maximum value of value 0. So this will produce always values in the range from 0 till scene minus width 1, and this will be bounded. So if I have -1 value, I will get out 0, not like the last value before 0. So this is useful. We should change it in that way. You could also change this in the template I gave you, but maybe leave it as it is so we can continue with the tasks that I was planned to do. So here we can change this part as well, the width, height. So this is the height part, so I will drop this into the Jamboard. We already a little bit running out of time because of this, but it's useful to understand better what you know and not. So I added that to the Jamboard. Let's see what happens now. Hopefully now it will not be, so it will work, hopefully. So let's see. Okay, so now it gets stuck, maybe. Yeah, it is super strange. So right direction. Okay, all the time unexpected things. So let's see. Probably I made some mistake. So position. Okay, the X is 0, which should not be that. So probably I made mistake in here. So the max value regards of 0 with this one, right? The mean value, yes, this is correct. So why it's not working? Let's see. So now I'm trying to set value to -1, but this is not what I need. Okay. Okay, so that's a little bit unexpectedly too long time for such a small task. So I will fix it now. So update, update, update. Okay, let's add the breakpoint here. Okay, now we are at the breakpoint. So the speed is something, the position direction is something. And then if I add breakpoint here, now the new change will be this. So it should fly in that direction. It should fly in that direction. And what is actually the output is probably totally wrong. Yes, 0, which should not be like that. So I definitely don't see something trivial here. Okay, so let's try to do this again. Watches. Okay. This was not expected. I will fix it correctly. No worries. I know definitely some kind of dumb bug. So okay. Now we are at the position. Then we try to change it, and then let's see if I have this constraint here. Okay, I know where the problem is. So here should be, if we check, then we do that. If we don't check, then we just set value, else value. Now it will work. So I will update Jamboard with these. So this is just one way how to do this. There are probably other ways. Actually, for the template that I was planning for today, I didn't have any of these kind of constraint changes, and it still worked. So it doesn't mean that you need to have them here. It's just one way to make it a little bit simpler. So now if I run it again, yes, now it's flying in that direction. Please fly in other direction. Yes, it's flying in other direction. Now it's flying back, and it's working. So now you only just need to add some kind of random element so that the spaceship appears sometimes, not always, and it changes directions and things like that. So hopefully that's clear so far. So now let's move with the template. So with the template, today's template, I mean. So where is my today's template? Okay, this one is actually my today's template, I think. So if I run it, okay, now I need to again set the emulate terminal. Run it again. Okay, now I have score in the top, and let me go quickly through the code so that you would know a little bit better it. So I have position 2D here. I created also a new class, vector 2D, that is the child of position 2D. Only difference is that I will not enforce checking the boundaries. Like with these, I have the checking boundaries. So the vectors can be in direction of minus, right? And so it should work. So that part is added. Then I have also a small question here, why we have a problem here. Maybe we'll discuss this a little bit later, but I improved this code, but still this code is not perfect. There is a possibility that the rocket will fly through the wall, and this is very logical reason why it's happening. And if you think about the code, you should be able to answer it by looking at this part and thinking how the main game loop works, but we will not talk about that now. Then we have a player, then we have a rocket, then we ask to implement alien. So what I mean by alien is actually this little guy I will post in the chat. So these small aliens that are coming down. So not actually the spaceship. So and now here we also have the singleton. So this is actually singleton. So this set of variables here inside self, so the player, the elements, the lives, the score, the listeners, aliens, the game running, all of these variables, they are inside this one group called game state. So if we want to save our game, we would then save all of these variables at one place. So it's not that they are like, we don't need to call global anymore in the places where we want to change something. We will call game state dot instance with these function call and then do something with it. And here there is again really interesting thing to notice. I am setting list of elements to another list here, but this is the same pointer. These are exactly the same memory location. So that's why I can operate here with elements, and I also can operate anywhere else with elements that are coming from the instance. Because if you think about how the rockets are added, right, or the explosions are removed or anything like that, we are operating with the game state itself, not with some kind of global variable. So you should think about that later. But let's look at one very important design pattern that we will implement together, and that will be kind of basis for these small aliens flying today. So I will go to the Jamboard now. So in the Jamboard, the first slide, we see that today I wanted to talk about the observer pattern. So the idea is that you have some kind of alien object, or just in this case, like baby, who is notifying observers, and so probably he's screaming, and in that way, all of the observers know that something just happened. In our game, what will be that we have these small alien class instances. So there will be instances of many objects, and these instances will have the function where will be like notify function or something like that inside all of these objects. And when this small purple alien will reach this side of the game or that side of the game, it will notify all other aliens that we cannot go in that direction anymore. Please go in that direction. And it will happen through the observer pattern. It will happen through the function pointers, or it could be also done in some other ways, but in general, the observers are just the function pointers in the broadest sense. And so the idea is that just this one instance can tell all other instances at once that we should do something in different direction without some kind of outside like, so we don't need to have something from the outside to tell them that we reached the other side of the screen. We can do that using the listeners. So there's a kind of a list of function pointers that we can use. I know that sounds maybe probably not clear, but when we start coding, hopefully it will become a little bit clearer. So let's then create that alien here. Yeah, let's share the screen just in a second. So yeah, so in the template now, let's do the alien part. So class alien. So just to make sure that you're following what I'm doing, so what should be the super class of the alien? What should be super class of alien? We have a lot of options to choose. Which should be the super class of the alien? What should the alien inherit? This purple guy. So we will implement this one. That's coming down from the sky. So what should be a superclass of alien? What should I write here? Okay, right, the movable element, that's correct. So because it's a movable, it's not, so it will not be at the fixed position. So that's good. Okay, I'm a little bit messed up the code. So yeah, okay, movable element, that's fine. So movable element, that's good. So then we will have some interesting properties here. So I think last time we already started using that in constructor, we can pass all sorts of things. So here in the constructor, we could pass, so I press enter like this. So we could pass some default parameters. So first of all, we have position 2D. By the way, this syntax of the colon and the type, this is just to help out for us to see, to better have the code auto completion and also to better understand the code. So this is not something that Python actually checks. So the Python do not check actually types. So this is one. Then there is direction. So direction will be vector 2D. And then we have the listeners. Listeners are aliens. So these will be the kind of um, the list of, okay, we can now add like that. So just a list of listeners that we will use. So then let's call super init. Okay, now it adds this. You can leave it as that or delete that part. Super init. Okay. So then by the way, what we have in the init position, alien class super, it's not missing. So I don't know what you mean by something missing. So I hope I'm not missing something. Okay, I don't know. Anyway, so then self position will be position, then self speed, we can set some slow speed, 0.5. Then let's say the character will be this guy, right? Okay, sorry, okay. Hopefully it's fine. On the direction, okay, direction will be direction. And then, okay, so then that's about it then. So then let's add the notify function. So def notify the new direction. So we will notify all of the aliens if we change direction. New direction. So self direction will be new direction like that. This is fine, I think. Okay, this will be fine. Then also let's add the so okay, yeah, so let's add also self listeners aliens to the object itself here. Okay, actually we can use with the underscore here. And now implement also the other, some kind of other function to check if we are check if we reach the side of the screen. So check well, border. So if we are close to the border, so we should check. So and the result will be um, is at border, and it will be false by default. But if 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 round self position x equals 0, so if the alien is either reached that side of the screen or round self position x equals seen with or the other side of the screen, and I think it's intentional that I didn't add -1 here. I will show you in just in a second. So if we reach any part of the screen, then we say we are at the border, true. And what we also do is we flip direction. So self direction x by -1. So we flip direction of the alien itself, but we also need to notify all other aliens. We need to tell all other aliens that we should change direction. And to do that, there is this idea of having those event listeners. So we have the listeners here. These are called event listeners or observers. In very beginning, they are empty now, but we can add them. So to make them meaningful, so we can add here append, append, and we should add append self notify. And the notify is actually function. So you don't add here these brackets here, no brackets here. So what we are adding actually in that place is it's actually not calling function, but adding function as a pointer. Again, you cannot get away from that. Like in any programming language, you will have all the time dealing with the pointers. You must understand them. You just need to like play around a lot of them until you completely understand them. Otherwise, it will be very bad. So here we are setting there is a pointer to this function, but not calling the function itself. So what is the difference? So if we would call this function, then it would look like this: self notify, and so set some kind of new vector that we will give as a direction. This will be a normal function call. But if we do something like this, so pointer, so this is actually pointer to that function, and then we can call it again using the same way, vector2d. So these two lines, again, you don't need to write them, but these two lines are exactly the same as if we would call it directly using something like this. So either we call function directly like normal way, right? Or we first get a pointer to function and then call the pointer. This is the exactly normal way in both ways. So the result will be exactly the same. I'm not sure if you understand this. So is this clear, or should we have look at more examples? So clear, or more examples. So the idea that you can call functions as in normal way, or you can get first pointer and then call that pointer as if it would be a function. And this is actually the same thing happening in both ways. Okay, if you're not responding, I assume that you need more examples. Mm. So as a more examples, I can give you something here. Let's make a quick small sample. Oh no, it's laggy. So new Python. And so okay, so let's make a small, very dumb example regarding the function pointers. So def dummy um, add. So let's say a b return a plus b, right? A very simple function, right? Print dummy add 1 3, 1 plus 3 will be 4. So let's run it. Works great, right? So very simple how to do this, right? Now let's have something like this. So there will be C variable that will be actually function pointer. There will be D variable that will be again function pointer, or it could be even function pointer to this guy. So then if we call it in this way or in that way, we'll still get exactly the same answer. See? Very simple example. So the idea that the pointer of a function can be then used as a function itself later. So it's the same as with the classes, with the complex data types. The pointer is very important to understand because they are used constantly all the time. So is that example clear? Is this example clear? Plus, minus. If minus, then please type in a little bit more explanation of what is not clear in this example. I can try to explain more, but as you see, very simple function. It's called, it's even not in the class. It's not even in the class. It's like the simplest function it can be. And you can use the function itself as a pointer to like some kind of, so all of these, the dummy add, the C, the D, all of them point to the same memory location. So again, this is regarding the complex and simple data types. Remember, the simple data types are floats, booleans, strings, the things that are not complex. So, okay. So in this case, at least you have the idea how it, now I give you that example. So we added this function pointer to this list. So we kind of have a list of function pointers. So now we have that list. That's great. So what we do here then, no, they are not function expressions. They are pointers. Again, I see in the chat, thank you for the question, but basically again, there is very simple logic down to any C language. It's like any programming language works with the pointers. Even JavaScript works with pointers. I will show you very soon. Like we will finish this game. We will make the same game in JavaScript, and you will see that there is no expressions. There are pointers. So okay, let's see. So here self. Um, but thank you for the question anyway. So it helps me to understand what is the level of understanding. So here, sorry, for so here will be the not if, so let's say function or something whatever, or listener. Let's go listener in um, yeah, so I think one thing that kind of makes a little bit clearer in programming is that nothing happens by default. There is no magic here. Like everything is tied to the memory locations, and there is no language that makes some kind of things that you think like using equal signs, something will copy and stuff like that. Like even JavaScript doesn't do that. So here the listener aliens listener. So we're going through these listeners. We are setting the new direction here. So we are setting the new direction to all other aliens. So what you see here that from this one alien, we command all other aliens to go in other direction. So really nice way how to do this. So then at the end we call return. Return is at border. Okay, so we say that we should we should stop looking for border because we already found one alien that is at the border. So we say all aliens turn in the other direction. So I think for this part, there's nothing else should be added. There are of course some things that should be added to make the game playable, but anyways, this class hopefully is ready. So I will drop this class into the Jamboard. By the way, I'm sorry that I'm a little bit rushing now. I will not really be able to stop right now with this code. So maybe if you're not finished with this class, then please carefully follow what we will show you next, and then later go to the Jamboard and video and complete this part, because I don't, unfortunately, I need to run before 6. So we have this part as for the class here. Then the next part is here in the game state or the singleton or this kind of global object composition, right? That we want to add the aliens here. And we also have already the listener here given. So this is also kind of nice example to show that we can pass the pointer of this list to every single alien. So we don't need to invent kind of like some kind of other way, like global variables or something. We just use the same pointer for all of them. So here we'll add, at least for the homework, so um, add 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 more aliens, add I think array of aliens. So let's make for the homework that you will add 5 by 3 array of aliens, 5 by 2, let's say. And but now we will add just a couple of them manually. So let's see. So then we also will have a random direction. So they will more in a beginning move in some random direction. So this will be so -1 by default, and then if random, sorry, if random random is larger than 0.5, because the random will give you from 0 till 1 this kind of random values. So in that case, we will move in other direction. And I will add manually 3 aliens, but you should then later add more aliens. In some, so you should add these aliens using for loops, so that there would not be like 10 manual lines, but just a smart way to change the number of aliens, so that you could have different levels with different difficulty and stuff. So here we have this part. Then let's see. So let's add alien. Alien will have position. And with regards to the position, we also need to create that one. So there will be position 2D. Okay, we can actually have it like with the new lines like that. So here, first one is position. First position will be 3, 3, 3. Then the direction, I think the second one was direction, right? Direction will be vector to the rand this 0. By the way, there is a smarter way how to make all of aliens fly in other direction, because you can use just one same pointer of direction for all of the aliens. But now we're just using the kind of this way to illustrate the usage of the observer. But that would be really smarter way, just to use same direction vector for all of them, and as soon as it changes, you don't even need to do anything there. So again, the power of pointers, pointers are really awesome. So then listener, aliens, self listener, aliens. So now we added this guy. Now we also should add it to the elements. So append alien. So actually I will add just 2, so I don't have time to, actually I could add 3 anyways. So here will be 4, position at 4, and then position at 5. So this is really a manual way how to add it, but you should change it using for loops. So it's really not smart way to do it. You can't imagine adding in this way 10 aliens. Just this would be super inefficient way how to do that. So you add this in the 5th slide. So this is the part where we add those aliens. And then the last part is that we need to check direction of those aliens here. And they should do that before the update. So then what we do here is we just go through the elements, and we check if type element is equal with alien type. then in that case, we want to check direction, check, or not direction, sorry, what was the name of that function? Check border, sorry, check border. Check border. So that's the last part here. Again, kind of idea of having object-oriented way that there is in some cases polymorphism, in other cases we just check specific types. So let's run it again and see what we get. So okay, the aliens are flying, I think. Yeah, so they fly in the one side and now they fly in the other side. So the first alien who reaches the border notifies the other aliens that we cannot fly in that direction. We should fly in opposite direction. So that's nice. Also, let's check and shoot them. Because oh no, I think there is some kind of mistake with rounding. Okay, I miss it. No, yeah, I got it. So anyway, I can shoot them. So you also can change the score when you shoot it. So that's kind of cool. And the one thing that's missing, that it's not going down. So to make them go down, oh no, okay. To make them go down, it's also a quite trivial change, right? So when we get notified that we should fly in opposite direction, when we got notified that we should fly in opposite direction, we just need to go down. So direction Y here, let me think in what direction should it be, is it should be the, actually we should, maybe even without direction, we can just change directly position so it have the behavior like in the original game. So just move one position down. So again, very easy stuff here. Yeah, so you should add that part as well. And if we try to run it again, now we should see that they are reaching this side. Then they are moving down and going like that. So really kind of simple way how to illustrate the observer and some other features that we learned today regarding the function pointers. So yeah, so I will add a homework, just a second. Yeah, so I will add a homework for this session. And next time we're gonna try to make the game finished. So the one thing next time we will do probably is we will need to have the kind of rockets flying from the upward direction down, and maybe even you could finish this whole game already yourself till the next time. So you will have this template, you have these small changes, you will have some couple of tasks, and let's try to finish it by the next time. So that's it for today. And after we will finish this game in the Python, don't worry, we will do exactly the same thing in JavaScript. So you will have opportunity to learn it again. And hopefully the next time when you do it, you'll have even more knowledge regarding the way how this should work. And then we'll move to the next topic. So that's it for today. Hopefully it was useful, and see you next week.